5-1, I believe we started with, I don't even know what the section was, but I know we did what's called mid-segments. Now, mid-segments in a triangle are the segments that connect the midpoints. That's why they have the word mid in them. Now, when we dealt with mid-segments, a lot of the stuff that we looked at we knew that each of the mid-segments was always equal to half the length of the segment it did not touch. So the mid-segments, they connect midpoints. They're equal to half the side not touched. And they're also parallel to that side. Okay? And that's where that stuff came from. And when we did these, a lot of them were pretty quick and painless. For example, if this was 7, this one, this whole side is 12, we're able to start figuring out basically every little bit and piece that's thrown in here. We'll say this one's 8. Make this up. By just knowing that little bit of information, you can fill in for all the rest of the segments that are there. Okay. So if I have 12 on that left side, what are each chunk going to be? 6 is good, because they're midpoints. So each chunk is going to be a 6, which means the other one that doesn't touch it is this guy, because it's a midpoint, which means it's also a 6. If this mid-segment is 7, the part it doesn't touch is going to be how long? 14, which makes each one of these. Means this one's the same. And then lastly, we have an 8, and lo and behold, another 8. Now, when you looked at those guys, we also talked about that you get 4 sets, or 4 different, 4 congruent triangles that are built into that larger triangle. We didn't have to prove anything with that. I think the only thing else that we did with that, and this is where I think you can correct me if I'm wrong on this, the only other thing we did once is like we did an angle measure. You know, if we said that this one was 37 degrees, where else is it 37 degrees? Well, it would always have to be between 1 tick mark and 3 tick mark. So 37, 1 and 3 is 37, 1 and 3, 37. I think that was about the only other thing we ever did. Yeah. So. Yeah. Ooh, yeah, let's pull up an algebra problem. It's a good idea. Algebra.
And you guys, I just looked in the book too, so when you go online to the Pearson book and you go to the chapter review pages, all of the answers for all of the review questions are posted there as well in the book. So you can go back into those selected answers for the chapter. They have all the review.
So back to the same basic idea of the diagram. When we did, and these are the problems we did yesterday. If I'm looking at just this first one here, or sorry, this one, where you have the segment FG, and then you have the whole thing AF. If I'm looking at that in terms of words, FG is centroid to side. You guys agree on that? That's why I write it out. Well, here's centroid to side is 1/3 the whole. Well, that's x plus 8 is 1/3 9x minus 6. From there, you have an option to do one of two things. You can take 1/3 of 9 and 1/3 of the negative 6 by the distributing it, or get rid of the 1/3 by multiplying the other side by 3. Either one is fine. In this case, I would just say distribute the third because they're both divisible by 3 and it's a little bit quicker. Okay. What's 1/3 of 9? And what's 1/3 of 6? So I get x plus 8 is 3x minus 2.
I asked
What?
6/10.
36 seconds.
36 seconds. Every single one of them is
Anyway, so I'm going to subtract x. I'm going to add 2 at the same time. And you get 5 for x. Okay. Now remember, sometimes it'll say solve for x, sometimes it'll say solve for x, but then it might ask you, hey, what is such and such of the segment? Okay. So you just got to read it carefully. And that's what we did with the centroid stuff. Remember, orthocenters, the only thing we talked about with the orthocenter were the altitudes. Remember we said where they could run into each other? When you have the orthocenters, yeah. When you have that orthocenter, that was where the altitudes meet. And the only thing that we worried about with those was where they could be within certain types of triangles. So in an orthocenter, if you have an acute triangle, a right triangle, or an obtuse triangle, the orthocenter would be inside, on, or outside. That's the only thing that we did with the orthocenter. That's it. There wasn't any math with it. It was just pretty quick and painless. You didn't have to worry about formulas or anything. Inside, outside, or on. After all that, then we did the 5/6, and the 5/6 was when you just had to worry about largest angle was always across the largest side, smallest angle was across the smallest side. And then 5/7, which you saw last night with the that hinge theorem, where you had that side angle, the included angle determined the size of the things. Okay. Questions on something that you want to double check before I give you a couple problems to look at? Super exciting. Actually, you know what? I just remembered I have this one saved. I forgot that I was going to show you this. Why don't you guys take a second? I want you to do a couple algebra problems real fast. So you have to figure out what kind of a segment is it, and what do you have to do to solve for it? Because that's the kind of stuff you have to be able to do tomorrow. So take a second.
Recently, actually. If I can check. Someone find that. What'd you get?
So what kind of segments are these? Yeah, they're mid segments. So the easiest thing to do here is knowing that this segment, if you double it, it has to equal the other side. So if you double x plus 15, you get 2x plus 30. Has to equal 23 plus x. Now, moving stuff around then, you're going to get x is equal to negative 7. Uh-oh, can you have a negative for an x? Yeah, perfectly fine. Because if you go back and look at it, what's negative 7 plus 15? 8. And then what's 23 minus 7? 16. So wouldn't that have to be half of it? Happens, guys. Want to make sure you guys see that. It happens. It's okay that you get negative answers because your segments or angles might not necessarily be negative. Okay? Yeah. Good. Now, this one here, those are angle bisectors. Find the measure of angle 1 if angle 2 is x plus 9 and angle DFE is 5x. Find the measure of angle 1 if angle 2 is x plus 9 and DFE is 5x. Well, remember, angle bisectors do what? Yeah, the angle bisectors equal each other, but remember they cut the larger angle into two equal parts. They if you double an angle bisector, you get the whole, don't you? So angle 2 is part of an angle bisector. So if you double it, it equals the whole thing. 2x plus 18 is 5x. Move some stuff around here. We get 18 is 3x. And gives you x is 6. Now it asks you to figure out what angle 1 would be. Well, what's 6 plus 9? 15. And if you double check it, what's 5 times 6? It happens to also be 15, or excuse me, 30, which is good because half of 30 is da da da. Just wanted to show you a quick little algebra reminders here. I'm trying to think if there's another one on here. How do you find the range of the possible sides? Okay. Don't worry about that. So what I did was your textbooks that we have now, a lot of the problems that they have thrown into it for as far as the review stuff, they're not bad, but they have a lot of software style problems. So I ran off a copy of the old textbook, so that way we can kind of go through that one. It has a lot more of the algebra to it. Let me see. I sense the sarcasm. Now on this sheet here, on this one here, I'd like you guys to do so skip 16. And yeah, skip 16. That's the only one on here that you don't have to be very much worried about. All right, those are some quick review ones. This should help you out a lot. And don't forget vocabulary, guys. You got to know which one's which. Circumcenters are angle bisectors, incenters the altitudes. Angle bisectors, orthocenters the altitudes, centroids are medians. Okay, we'll go from there. All right.
Correct.
Give them background.
Yeah, remember guys, when you were on an angle bisector, you were always equidistant to the endpoints of the segment. If you were on if you're on the perpendicular bisector, you're equidistant to the endpoints of the segment. If you're on an angle bisector, you're equidistant to the sides of the angle. That's what I was talking about.